All right, for the first talk today on the main stage, it is my great pleasure to announce how to really annoy your hoster with load testing at scale. We have Martin Helmich from Mitwald. Please join me on stage and give a warm round of applause for Martin.
Thank you very much. Good morning, fellow humans. Welcome to how Juliet called it yesterday evening, the hangover slot. I'm happy that you're all here, that you made it. I'm only moderately hungover, so yay for me. My name's, hello, clicker. There we go. In case you don't know me, my name's Martin. I'm in charge of developer relations over at Mitwald. And full disclosure, please don't get the pitchforks out. I'm also active in the Typo 3 Association, but I come in peace. And I would like to start by telling a story. Once upon a time, we had a customer who was hosting a little online shop on our platform. It was a little WordPress site. It was using WooCommerce. It was maintained by a solo developer. And the customer of that online shop, it was You'd probably know him if I told you the name, but I'm not going to. It was a major German rapper, and they only sold a single piece of merchandise on that shop. It was a particularly ugly sweater. It was like the most ugly sweater that to that date and since that date I had ever seen. That's not it. That's just what you get if you ask ChatGPT to draw you an ugly hip-hop sweater. And that shop actually worked reasonably well. Until that particular artist happened to release his new album on I think it was a Thursday evening at 8. And everybody and their grandma wanted to buy that particular ugly sweater. Sucked to be us at that moment. I still don't get why everybody wanted this particularly ugly sweater. So maybe a different question. And at that time, the site went down. They called us because their site was down, and they weren't particularly happy about it. So this was how I felt like just hands-on firefighting mode. We were trying to scale that site, which wasn't particularly easy because that little WooCommerce online shop wasn't even built to be scalable. You know, as a hosting company, it's easy for me to say that we can just throw hardware at a problem. And we can, but if you want to be scalable, there's actually things that you need to think about. For example, like centralizing your session storage, wondering where to store your assets, and that site had none of that. So we tried to botch that together on a Thursday evening for the customer on short notice. Didn't work. We desperately tried to put a varnish in front of it, which didn't work because if your backend's already down, good luck getting a cache warmed up. So actually, we tried everything, and that site was just down for I think like half an hour, and then it died down, and the site became available again. But in that moment, there was nothing that we could actually do on short notice to make that site available again. And there are actually many reasons why a site might fail under load. It might be simple resource exhaustion. Again, as a hosting company, it's easy for me to say just throw more hardware at it. As long as you're paying us for it, I don't really mind. But then you might get architectural bottlenecks because maybe your site's not even built to scale out. Maybe you have that one particular database query that needs an exclusive table log for whatever reason. Maybe it's just shitty coding. Maybe your server isn't configured right. And I've also already seen performance bottlenecks because DNS and .resolve settings weren't configured right, which added like a second of latency to every request, which is particularly annoying because it's very easily avoidable. So there's many reasons a site might fail under production traffic. Another story. If you take a closer look at me, you might notice that I enjoy attending festivals. I happen to collect the badges, and it's June, it's getting summertime, so festival season starting again. That photo I took a few weeks ago, that one I took last year, and I particularly enjoy the vibe at festivals. I enjoy how music has a particular way of bringing people together, and which is why I enjoy spending time at festivals. And which is also why I was particularly excited when the other day a customer reached out to me, and they said, Martin, we have a festival site hosted on your platform, and the ticket sales coming up. Can you tell us if it's going to be available or not? Because for whatever reason, that was really important to them. I don't know why. I can presume. And I told the customer, well, if you really want to be sure, you should do a load test before if you don't want to find out the hard way. So the festival under test that we're talking about is one of the largest electronic music festivals in Germany. They have around 225,000 visitors every year. And the site was built on Type 3, sorry. But everything I'm about to tell you about load testing can be applied to basically any tech stack. That site was built on Type 3. It ran on a single server setup because if you're familiar with Type 3, you might know it's also a bit cumbersome to horizontally scale out. I think I'm allowed to say that. So we decided to just throw hardware at it, and it was running on a single server, like a little bit bigger than what we regularly sell to customers over the shelf. It had 192 cores, 500 gigs of RAM, and using average traffic that was completely over-provisioned, but they wanted to be prepared for the ticket sales scenario. So when talking about load testing, let's talk about tools that you can use for that. In the most simplest case, back then when I started worrying about infrastructure and scalability and whatnot, there were tools like good old Apache benchmarks. You could call AB on your command line, just told it do 100 requests in parallel, and then you'd get an output like this, where you basically it would just call that URL that you gave it in an endless loop, and you'd get metrics on your average response times, how many requests per second your server could handle, and blah blah blah. My issue with Apache Bench is that Apache Bench does not really mimic realistic traffic on your site, because first of all, no user is going to in an endless loop invoke your index page over and over again. No user is going to be using HTTP 1.0, which Apache Bench does. So what we wanted was a testing tool with which you could mimic user behavior realistically. And we also wanted a tool with which we could verify if the SLOs, the service level objectives that we agreed upon with our customers, were actually met during that load test. Because they said things like, oh, well, during ticket sale, we want for example, the 59th percentile of load time to be less than, I don't remember. And the cherry on top would be if we had a tool that we could use automatedly to integrate into CI and other automation processes. And using these requirements, we came upon Grafana K6. Grafana K6 is an open source tool. You can download it from GitHub. It's just a command line tool. It's built in Go, but it allows you to script your load test cases doing JavaScript. I guess I don't have to explain how JavaScript works. This is how a really, really simple K6 load test might look like. You have that options array in which you configure with how many virtual users you want to hit your site. And then you have that default export in which you can programmatically describe how your virtual user should behave. You can do HTTP requests. You can also implement complex click paths. I don't think I have to explain how JavaScript programming works. Everything that you can describe in JavaScript, you can implement in a K6 load test, and you can use that to try to code how a typical user would behave on your site. Output might look like something like this. This is just a short demo. I'll show the output of the real one in a minute. And then we proceeded to define scenarios together with the customer. And what the customer told us was that during ticket sale, we're expecting like 50,000 visitors on the site, and 25 of those arrive within the first. 25 of those we have in the first 5 minutes. And that in itself is not particularly bad, but what's bad about is that they're all arriving at the same time. So they're announcing like a specific date at which the ticket sale starts. They're announcing that on social media and whatever, like Thursday 10 p.m. ticket sale starts, and then everybody's hitting that site at the same moment. So this is the scenario that we modeled after that description from the customer. And mind you, what's important is we're talking about visits. We're not talking about requests. So each visit has, in our case, modeled a click path of whatever pages the user navigates to when actually buying a ticket. And then you also have all the HTTP requests to load the assets for that, which is also an important part of a load test, because if the user is going to call your site, they're not just going to call the index PHP, they're also downloading the entire site with all its assets. So actually this translates to, if we assume that each visit is roughly 120 HTTP requests, that translates to about 10,000 requests per second to the web server. And particularly interesting is that they're all arriving at the same time. So, but what we're doing is essentially it's called a spike test. If you try to find out how your server behaves if a lot of people arrive in a very short amount of time, which maybe in some cases might be a malicious scenario. It could also be a DDoS attack, for example. But in the case of a festival site with its ticket sale of an artist who drops his new album, we've had customers who were on, in Germany it's Höhle der Löwen, I think in English it's Shark Tank or whatever it's called. So they had a TV advertisement. Same thing happens there. You could also code your test case to include like a short ramp-up phase to give your server time to adjust to that traffic. But in some cases, that's not a realistic scenario. Because in some cases, festival ticket sales, they actually do come all at once very, very quickly. And these kinds of spike tests are particularly nasty, because if your cache isn't warmed up when that scenario starts, it'll be too late. So you cannot rely on caches warming up when traffic starts arriving. If you're using autoscaling, like in a cloud platform, that won't help you, because that is always reactive. And these things tend to happen very, very quickly. So that won't help you. And you might have network security in place who might actually confuse this kind of traffic pattern with a DDoS attack. So you might actually end up excluding certain users because your network security thinks it's an attack. In the case of the ticket sale, this is the scenario that we modeled. We assumed, or rather we knew, because we had access log analysis and could infer from that how users were behaving, that most visitors during a ticket sale would head straight to the ticket page, And then we weren't even hosting the ticket shop itself. That was a SaaS service that was hosted externally, but people were still hitting the festival site and then navigating their way through to that ticket shop. And we assumed that a certain small percentage of users would also randomly navigate around the site for a bit before finally heading to the ticket sale. That was one scenario. We also had other scenarios. One other scenario that was important to the customer was the artist announcement, which also had a certain traffic spike in which other sites were preferably called. The third scenario was the on-location traffic that people cause when they're on the festival and visit the festival site from within the festival venue to, I don't know, get to know where facilities are, to get the map, to know which, to know the running order for the specific day and whatnot. So we also had scenarios for that. Thing with Grafana case 6 and with that test case that I showed you earlier was that I mentioned we're not just doing HTTP requests to that index PHP, right? Because, or rather, that's not what a user does, because a user is using a browser which downloads the entire site with all its assets. And in the test case I showed earlier, we were doing exactly not that, because we were just doing simple HTTP protocol level test, which again is not realistic, because actually we want a load test that mimics user behavior realistically. So if we have a look at how a browser executes an HTTP request, and also what is the metric that we actually want to test and what we want to optimize for, is it that one, like that the duration of that first HTTP request? We can do that, but that's not ultimately what the user cares about, right? So who cares if that index PHP is served in 80 milliseconds, and then you have that 200 megabyte video which blocks your loading and takes 2 minutes to load. So what then? Do we use the load time? Do we use the finish time that the browser tells us? Actually, that's a solved problem, because there are well-defined metrics for just that. So we can do a short excursion to the core Web Vitals metrics. Who's familiar with those? That was not well thought through, because I can't see shit from above here. The core Web Vitals are a set of well-defined metrics to measure loading times, to measure interactivity, and to measure visual stability. So for loading time, we have the largest contentful paint or first contentful paint. For interactivity, we have that interaction to next paint. So for example, if you interact with the site, how long it takes for the site to visually react to that. And visual stability is the cumulative layout shift, because everybody's seen that particularly annoying ad that loads like 5 seconds later and then everything shifts down. So for a load testing case, obviously those loading time metrics are particularly interesting. LCP is defined as, if you're looking at the total timeline of how a page loads, LCP observes when the largest paint happens. So measured in its relation to the viewport size. Everything below 2.5 seconds is considered as good. Everything below 4 seconds is considered as, well, could be better. Everything above 4 seconds is, no, don't do that. And we can also measure this with Grafana K6. You can configure K6 to run a browser test, actually. The options in that case would look like this. You basically give it an option and say, please start a Chrome for this test. Do so with 20 virtual users for 15 minutes, and then you can define, which is also nice about K6, you can define thresholds in which you can define which metrics should fulfill which conditions, and in those threshold definitions, we can test for those core Web Vital metrics. Obviously, this thing is going to start 20 Chrome instances, so mind your memory if you're doing that. And obviously, you're not going to do a load test with tens of thousands of parallel users. We'll get to how to achieve that in a second. The test case, in that case, would look like this. So the actual virtual user function. That API is designed to be compatible with Playwright. So if you're familiar with Playwright, this might also look familiar to you. And what we actually ended up doing, because I mentioned you won't be able to start 1,000 instances of Chrome. So even if you're going into the cloud, that's just ridiculous. So what we ended up doing, which is also something that is officially recommended in the manual of K6, is to run a high-level, like a high-volume test in the background to make sure the server is under the load that you expect for that test case, using just basic HTTP protocol level test, and to then have a second test suite run in parallel that runs with a, let's call it, moderate amount of parallel browser instances. I wouldn't recommend doing one, because then you're very susceptible to noise in your metrics. So I would recommend starting as many browser instances as you can afford using your memory. I don't know how much memory does a Chrome instance take. Like, I think it's around 300, 400, 500 megabytes. That would be fine if the customer didn't mention that they also wanted to ascertain the bandwidth usage of that project, which you cannot realistically ascertain if you're just hitting the index page. So what we then got around to was writing a K6 plugin into which you could plug HAR files, which is what you get if you open your network tab in Chrome or Safari or whatever, and you export all those requests that are being done. And then you can actually replay those with K6 without having to start an actual browser, except that we still need to start an actual browser to get those core Web Vital metrics. We also argued, hello? We also argued a little bit about doing an online or an offline test, so meaning whether we should hit the production site directly with our load test, or if we should create an offline copy for that, and there are good reasons for both. Obviously, if you're doing a spike test like this, you have to consider the possibility that you're taking the site down with your test, which we did. The customer gave us a maintenance window, and in which they had not that much traffic. Anyway,
Simultaneous recovery test.
yes, exactly, simultaneous recovery test. Over the course of the test, we decided to clone the site onto an identically sized testing lab environment. But depending on how big your infrastructure is and what your budget is for the test, that might not always be an option. And if you're not stress testing, if you want to just see if your server can handle the expected average load, like not spike testing, but average load testing, your production system should be able to handle that kind of load anyway. So might need to, there's no right answer on that. What we also thought quite a lot about was how to size your testing environment, meaning how to size the machine that you're running K6 on, because this was an HTOP screenshot from our K6 testing machine. Because if you're not paying attention, that can also become a bottleneck. Because in that case, the server itself was actually quite bored, because there was a varnish in front of it, and varnish is really efficient at handling many requests in parallel. But in this case, our testing machine became the bottleneck. It also took around 50 gigs of RAM, which is moderate for that. So if you're doing this on a high scale, there are kernel parameters that you need to set, like, for example, port ranges and connection reuse and whatnot. Those can quickly become a limit. You need to think about memory. If you're doing protocol level tests, K6 is really efficient, and they tell you to assume like 1 to 5 megabytes per virtual user. So if you have a beefy machine, you can easily handle thousands of those. When you're doing browser-based tests, obviously not. And if you're CPU considerations, well, it depends on how your test looks like. Obviously, we're doing HTTP2 requests. There was TLS encryption. There was compression, which, again, we wanted a realistic test case, but that's going to keep your CPU busy for a while. You also need to consider bandwidth. For example, if you translate that to 80 visits per second, and then you have like the average page weight, because that page was heavy. There were large images. They were optimized, but they were still large. There were videos on that. There were interactive elements. So each click journey through that site had a weight of like 1 to 200 megabytes. So translate that, and you get quite a lot of bandwidth that you're going to need for that. This was the actual output that we got in the end from one test case in which we did like roughly 6 million requests in I don't remember how long. Grafana tells you over there are the over there we have those core web vital metrics. We get statistics for those. You can also see if those thresholds that you defined were met, which in this case they were not. So basically, you have everything in metrics that you need in there. If your testing environment gets if your test gets so large that you cannot comfortably run it on a single machine, you can also split up your test case into your test runner into multiple execution segments, which you can also do. In which case you can just have as many machines as you want in parallel. Have your test cases run from there because they're stateless, and you can easily divide them up into separate execution segments and then aggregate the data into a common data source. We started using InfluxDB for that, but then we noticed that this was way over the top for what we needed, because we could also just dump all the metrics we had into a CSV file and then just pipe that into Jupyter, which actually worked out way better. Only thing that you need to be mindful of is that you're getting very detailed metrics on your load test. So in 50 minutes, we got around 30 gigs of CSV files, which may be a strain on whatever machine you're running your Jupyter notebook on, but, well, I paid for 64 gigs of RAM. I'm going to use 64 gigs of RAM. And then you get nice metrics like this. This was from one of the test cases in which we actually, there's an interesting phenomenon happened there, because you can see the point where we hit the CPU limit on the testing machine, which caused the request rate to die down. So that's obviously something to watch out for. And below there we have the largest contentful paint metric, which was okay-ish for most of the test, except that probably we should have started more Chrome instances to have a better average and to reduce the noise a little bit. So before I finish, I have one last important service announcement. If you want to try this out for yourself, it's important to note that these kinds of load tests, some kinds of these load tests, are indistinguishable from denial of service attacks. So if you do not own the infrastructure end to end, please get a permission to attack from your infrastructure provider. As a hosting provider, we typically grant this if you're on your own hardware. On shared infrastructure, obviously not, because you're going to ruin somebody's someplace, sometime. You're going to ruin someone's day. And also, if you're in the public cloud, also mind your traffic bill, because if you're paying per gigabyte egress traffic, that might get expensive real quick. So I think I'm only 2 minutes over. So thanks for your attention. If you have any questions, I'm here for the entire day. Thank you very much.
Thank you very much, Martin. And we do have some time for questions. So
Amazing.
None submitted yet. Anything coming to mind? That was a cool presentation. I liked it very much. Thank you.
Thank you.
And as Martin said, if you have any follow-up questions, you'll be here the entire day. So
I will.
just walk up to him and ask your question. And we do have a little present for our speakers.
Awesome. Thank you so much.
You get one of our paper ants to take home with you as a mascot, and Neos honey specifically made for us. So enjoy that.
Thank you. Thanks for having me.
And next up at 10 a.m. here on the center stage will be Sebastian Helzle with his talk about building better Neos backend modules with HTMX. And on the studio stage, David Sporer will talk about using VR for remote work. Does this actually work? So enjoy your break and see you back at 10.